Contingency tables, also called two-way tables. Okay, so what is a contingency table or a two-way table? It relates to categories of data. So what categories? For example, employment status and education level. Education level is represented by columns. Did not finish high school finished, some college, and a bachelor's. And the employment status is presented on rows, either employed or not employed, or not in the labor force, not interested, or maybe self-employed, or who knows, not in the labor force. Okay, so a contingency table will help us understand if there is an association between education level and employment status. So first of all, we have to determine what is called the marginal distribution. It can be a frequency or a relative frequency of the row or column. And then we'll answer different questions on this table. And then we can choose other tables to work on. So I have to copy the table because it's too small for you to see. You do have it, you don't have to copy it unless you want to. Education level and employment. MP status. Leave enough room so we can create another row and another column. So make sure that you have, that's why I left some room for you here and here to continue. Okay. So we have 1, 2, 3, and this will be the marginal distribution by row. Right here. This will be the marginal distribution by column. Okay, so I'm copying the data quickly. So we have different, and I'm not going to copy the whole thing, just the numbers. So I have 9699, 33677, 34750, 48. I didn't create enough columns. 48134. Okay, and then the next one 1049, 2565, 2272, and 1625, and last one 14896, 26244, 17744, and 16322. Okay. First of all, what is called relative. What is called frequency, and then relative. First, frequency. The frequency is basically the total. I'm sorry, I forgot to turn this off. Yes, Tao, are you calling me, Tony, because of MyLabs Plus? Yes, Robin told me. I'm in the middle of my class right this moment. If it's not about MyLabs Plus, then I have to call you back. Yeah, I mean, you can copy it if you'd like. I mean, if I need to add something, I will add. So are there any changes for the winter course? No, I mean, I can use my own then. Okay. Thank you. That's okay. Bye. I thought it was about MyLabs Plus, but she's another colleague of mine. My apologies to everyone. Sorry about that. So the frequency is basically the totals, as we did before with other variables. So we have to create a total for each row and a total for each column. And of course, we are going to check with the total for grand total called. Okay, so each row, 9699 plus 33677. Check my numbers always, please. 34750, 48, 134. For the first one, I got 126260. Please check my numbers. I need anyone to confirm. 72, 7511, 14896 plus 26244.
Your first column or row is right.
Thank you very much. And 75206. And now columns. 9699 plus 33677 plus 3470 plus 48134. Oops. 9699 plus 1049 plus 14896. 25644. 33677 plus 2565. 26244. 62486. 34750 plus 2 plus 17744. I got 54766. 48134 plus 1625 plus 16322. And I got 66081. And now I have to make sure that these three added up will give us the grand total, and these four added up will give us the exact same grand total. Otherwise, there is an error somewhere. 6260, 7589, 75206. So I got 208977, and I'm checking now with the total 25644, 62486, 54766, and 66081. I did get the same thing, so apparently I'm okay. So this is the frequency for employed, not employed, not in the labor force. Total for did not finish high school, finished high school, some college, and bachelor's degree. Okay, that was the frequency. Then in step number 2, or the question is asking us as well. So find the frequency marginal distributions. We did. These are the frequency marginal distributions for employment status and level of education. Part A is finished. Part B, determine the relative frequency marginal distribution for level of education and employment status. So we are going to divide for the relative frequency. We're going to divide each entry, each frequency by the total. Okay, I'm going to put it in a different color next to the same entry, so you know where it's coming from. So I'm going to use this color now. So 126260 divided by the total, 7511 divided by the total, and so on and so forth. So 126260 divided by 208,977. Let me see if I want to do this. 208,977 stored in. I want to store this number and use it several times, but that's okay. I don't want to waste the time. So divided by 208,977. So 0.604. 7511 divided by 208,977. 0.036. 75206 divided by the same number. 0.360. Okay, 25604 divided by 208977, and I have 0.123. 62,486, 28977, 0.299. Two more, 54,766 divided by 28977, and I got 0.262, and 66081 divided by 208,977. So 0.316. So these are the relative frequencies. Any questions so far? Any questions for me? Any questions? Can we move on? So this was part A and part B. Maybe I should write A and B. What proportion of those who did not finish high school is employed? That's part C. So at this point, we're only looking at the column who did not finish high school. What proportion of those who did not finish high school is employed? So it's this number divided by this number. So from those who did not finish high school, the proportion of employed is 9699 over 25644. And that's the proportion. 9,699 divided by 25,644. Okay, so the probability is 0.378. Next question. Part D. What proportion of those who are high school graduates is employed? So this time that they're asking us to find from those who graduated from high school, what proportion is employed. So the second column is those, it refers to those who graduated from high school. So employed will be this number over this number. So proportion, knowing that they are they finished high school, what is the probability of employed? And that would be 33,677 divided by 62,486. Knowing, so this piece is knowing they graduated from high school. What is the probability that they are employed? Okay, so 33677 divided by 62,486, and correct my numbers anytime. 0.539. Next question. So this was part D. Next question, E. What proportion of those who finished some college, this is the third column, is employed? So this time we want this divided by this. So it's another conditional probability. So the probability that they're employed given that they have some college. 34750 divided by the total of 54,766. Any questions, anyone? 54,766. Okay, I got 0.635. Final question so far, before we have something else to do with this table. What proportion of those who have at least a bachelor's degree is employed? So finally, the last column, at least a bachelor's degree is employed. So The probability that given that they have a bachelor's degree, what is the probability of being employed? So that would be 48,134 divided by their total of 66,081. 48134 081. Yeah. So I got 0.728. We learn a lot from these contingency tables, as you see. And we can answer a lot of questions.
I have a quick question.
Yes, please.
Why didn't we go over this with the rest of 4 earlier in the semester?
A very good question, because it's related to chapter 12. Excellent question.
That's fair. Okay.
Yes, that's why these two are together, because we are going to see the table again here in chapter 12. That's the connection.
Okay.
As I mentioned, Sean, I'm not on the committee. So the lady who called me, she is the coordinator of this course. And I'm on the calculus committee. So I did not participate when they made decisions on what to put on the homework and which section to teach. They did. This committee did. And they said, okay, I think that it's important to see those tables, the contingency tables, right before we look at inferences on categorical data, because of these tables that are used in this chapter. So that was the reasoning behind it.
Okay.
Very good question. Maybe I should have mentioned that. But thank you for your question.